Hey, good morning. Welcome. Pardon me. I can see a few of you are out there, so thanks as always for joining me for the live stream. You guys had a great run through last week's lab, so I was glad that it looked like everybody um, got through that lab successfully. Um, like the overall just patterns that I'm seeing is that everyone's just right on top of everything, just as they should be. Hello, Islam. Nice to see you. So keep up the good work. If you are struggling in any way, which is very few of you, but if you are, don't forget Piazza is a good place to get help from me and your classmates. Office hours are a great place to get help. You can book one-on-one time or drop in on the group part. Some people are dropping in on the open office hours just to hear what other people are asking about. Um, and sometimes their own questions are probably being asked and answered. So don't forget those things. Pay attention to formatting. Almost everybody is nailing the formatting perfectly, but there's a few people whose source code is not formatted all that great. And by a few, I mean like 2 or 3 tops. Happy Monday, Edcast. Nice to see you. So anyway, keep up the great work. If you have anything that you have questions about, please use one of the various channels we have to ask and then answer questions and get help. Okay, so the big thing on the agenda, the project 1 is not due till October 2nd, which is a week from next Sunday, right? What's today, the 19th? Yeah, so 2 weeks, 1 day short of 2 weeks. But unless you know for sure how you're going to do it and how long it might take you from experience, I don't recommend you waiting till the last second. I don't sit around and answer Canvas inbox on Sunday nights, and I always feel bad for people who are sending desperate messages out on Sunday night. So best to start early if you can possibly manage it, and then you have plenty of time to reach out through the various channels where you can get help. There are some good design ideas in last week's discussion. If you're not in the habit of reading your classmates' posts, there are some people with some good ideas with some links to design tools, with some specific sort of architecting ideas. Using a struct is one example that I can think of to represent an item. At least one of you noticed that hint, I might have actually sort of already given you a suggestion in that direction, which doesn't mean you have to use it, but if you're fishing about for ways to go to solve the first project, they are out there amongst your classmates, and I've dropped a few hints here and there as well. Okay, project 1. Yeah, so let's just go on and do new stuff. We finally get to the fully object-oriented part. This class will be object-oriented most of the time, like fully object-oriented, so defining classes, putting them in their own files, creating instances to put together applications. But you're not prohibited from using structs or just kind of plain old functions where those make sense. So you'll see me take the object-oriented approach from here on out, just because I think it makes good sense to do so. But when you are left to make choices, say on your projects, occasionally you can make whatever choice is the most sensible to you. So let's go down. Individual project is highlighted on the home page. And let's walk through week 5 and then go do some object-oriented C++. So we will be declaring and defining a C++ class, and we will be doing it in separate files this week. Most of you have this experience. If not, I hope that this is sort of a soft landing for it, because I've already set up the lab with the separate files, and you just have to go locate where to do your implementation. We will repeat the work of using O-string streams to create string representations of things. And then I'll also talk about the new thing that you're seeing in the unit test, which won't affect your life at all, but if you are reading the unit tests, which you should do, then you'll notice that I did something. I added a little extra thing or two this week. which won't change the way you click run and REPL it, but at least it maybe gives you a sense of the other possibilities with our unit testing library. Readings as always. Yeah, nothing new there. I will come back to the lab. It's a unit tested one, but it has multiple files in it. So you'll notice that I'm linking you to a repository that has multiple files sitting in it. So we'll have a quick peek at that before I close out for the day. But just heads up, there's multiple files to go into your REPL this week. And then what I like to use the discussions for in your class is to go out and do a little bit of supplemental learning, things that we might not have time to do. At least I don't during the live stream, that I might try to get discussions about in a live class. So this is just kind of looking at the history of computer science and people who have played interesting or important roles in the history of computer science. This is a very short list because we don't have a big class, so I think it'd be more interesting if we just get more detail on fewer people. So that's what we're going for here. And then reminders, so the project is due sooner than you think, so please don't wait till the Sunday that it's due, which would be October 2nd. Get a start on it. You already know everything you need to know to do it. It's just a matter of how fancy do you want to make your implementation. After today, you'll have every tool that you would like to have at your disposal to implement the project. And I recommend, I'm going to open this and say it now. One of the reasons to read your classmates' discussion contributions is because your classmates have smart ideas in them. So, for example, you have a classmate in the week 4 discussion who referenced this thing here, who said they're going to go look at how to use that and consider using it in their project. So that person had clearly read the project, and they shared with all of the rest of us the fact that they had read it and thought that they might go have a look at this thing to see what it is. Someone during office hours last week came in and asked me about it, which is another way to go about it too. But those are the kinds of things that should make you want to see what your classmates are thinking, which you can do through the class discussions. And then possibly start kicking around ideas in separate posts as you're beginning to design your application and then implement it. Okay, so anyway, good on you, the person who noticed that that was sitting there. Okay, so let's switch over to REPL it, because I don't have anything else to talk about really that just isn't looking at code today. This is week 5. That feels pretty good. And I am gonna, let me move that to the bottom. Okay, so let's start with the most basics. And the most basic thing is to compare and contrast a struct with a class. And we're not going to do separate files at first. We're just going to do the concepts. And one thing I'll point out to you right off the bat, make sure you can see all that okay. To point out to you right off the bat is when you declare a struct or a class, you declare it inside of a block, and then the declaration is closed with the semicolon. That has to be that way. And if you leave that semicolon off, which is easy to do, the compiler errors can be weird or difficult to read. So let me just try to compile this, having removed the semicolon from line 5, and let's just see what the error messages look like. Yeah, error oh, this one was good. So the compilers are getting a little bit better. Depending on the way you have your files structured, you may not get this kind of help from the compiler. In this case, the compiler actually said, hey, line 5, there's supposed to be a semicolon there. So thank goodness for that. I hope all the compilers are presently doing that. That has not always been the case. but I just wanted to see live what was going to happen. So that semicolon has to be there. And thankfully, the compiler that Replit is connected to is pointing that out. Okay, so structs and classes in C++ are almost exactly the same. And in fact, if you know just a little bit of what you're doing, you can implement a struct that has precisely the same functionality as a class, and vice versa. You can implement a class that has precisely the same functionality as a struct. So that can be confusing because then you want to ask the question like, well, when would I know when I am supposed to use a struct versus when I am supposed to use a class? So for me, I think of a struct as a handy way of gathering together multiple related variables, and that's it. And I want it when I am gathering those variables that I want easy and convenient access to those variables. So I have an instance of the struct, I use a dot, and I access the variable. That's when I use a struct. I use a class when I also want to gather together variables, but I imagine implementing a series of functions to associate with that class that do more logic with the data than a simple struct would do. And I'll try to build up an example so that makes some kind of sense. So let's just start by implementing a box with an int x and an int y in it, and a simple box, and a fancy box with an int x and an int y. Now, the style that I've used on my struct is good style. The style that I've used on my class is bad style, which you'll see in just a moment, at least in my opinion. This is not the way you would want to see someone implement a class in C++, but this is the way you'd expect them to implement a struct. Now, why am I saying that, and what does that mean? Well, let's implement simple box 1, and then a fancy box, FB1, and then I'm going to do some initialization, so sb1.x. This is why I would make a struct, is because I want this kind of convenient access to the data members inside, but I still get the sort of overarching container that I can pass to functions like we did last week, return from functions like we did last week. I can move the container around and have references to the container, and then understand that I can use the container to dig in with the dot syntax to get the variables out from under it. So let's just make this like 10, and sb1 dot y equals 0 just for fun. And then we will do fb1.x equals 10 and fb1.y equals 0, and then try to run the compiler. So I made an instance of the simple box and attempted to initialize its data members. And I made an instance of the fancy box, and I attempted to initialize the data members. I'm saying data member. Those are the variables that are declared inside of the class or inside of the struct. We would call those data members. They are members of the class or members of the struct. The fact that I called them X and Y in both places doesn't mean that they're related in any way. Simple box has an int x and an int y, completely separate from the fact that fancy boxes have their own int x and int y. I'm going to try to run this, and we will see immediately, I hope, the difference. So here is the actual difference between structs and classes. So notice I have no errors here. I have an FBX and an FBY error. So I only get fancy box errors. I don't get simple box errors. And this is the only difference. Structs expose all of their data, and if they have functions, structs expose everything inside of them to this dot access by default. And we would say that structs are, all the members are public by default in a struct. Public by default. Which is why I can use the dot notation to access those members directly. With a class, everything is private by default. So that's literally the only difference as far as I'm aware, is that a class, everything in it is private, and that means that you cannot directly access those things. Whereas in a struct, everything is public by default. Okay. Turns out, however, that you can override those behaviors with access modifiers. So I can, for example, use an access modifier, which is, in this case, the keyword private with a colon behind it. I can use an access modifier to modify the permissions on everything that follows. So what I've done now to the struct, I've made x and y private with this access modifier. And the box, I'm going to make everything public with an access modifier. So Isnam in chat asks, with a class, can you have member functions? And the answer is yes. So Islam, you can have member functions in structs and classes both. We will occasionally use member functions in structs, but rarely, just because that's not kind of the typical style that people use with a struct. But it is the very common style to have functions implemented inside of a class. So no, both can have functions. It's actually more common for a class to have member functions and less common for a struct to have member functions, but they both can have member functions. So the only difference between them is this default access. So I'm using access modifiers here just to switch the default behaviors of the struct. Now everything in the struct is private. Now everything in the class is public. And if I run it, you'll see that the errors are now about the struct and not the class, because I've overridden the default access with access modifiers. So you don't see a whole lot of people, I mean, you'll see it, but I don't see a whole lot of people using access modifiers in their structs. I do see them as sort of the standard approach to writing a class. Okay, so that's the difference. Everything else is the same, and you can change the default behaviors of both with access modifiers. So we're going to get rid of the struct. We don't really need that to do classes. But other than that default, structs are public, classes are private, everything else is the same. They can both have constructors, which we'll talk about today. They can both have overridden operators. They can both have member functions. They can both have data members. And they can both have all of the access specified with access modifiers inside of them. So you can literally implement structs and classes that are completely interchangeable. But the common approach to structs is that we just use them to collect variables, and we accept that those variables are going to be public. Actually, I should have left the simple box here so I can do one more example off of this. So in chat, Edcast asks, when would I use a struct versus when would I use a class? I would use a struct when I want multiple variables and I want the convenient public access that defaults in them. I would want a class when I want private variables that I will control more carefully with member functions. So I don't write many member functions in structs. Occasionally I'll take advantage of the fact that I can do that with a struct, but typically I think structs are variables, and that's it. And then with classes, I think classes are private data and public functions. So I use a class when I want to use functions to have more careful control over the variables inside. I'll do an example here just so you can kind of see the difference. So one of the downsides of my simple box right now is that I can do something like this. I'm going to do the big old namespace standard so I can get this to go faster. So one thing I can do right now is I can do this. sb1.x divided by sb1.y equals sb1.x divided by sb1.y end line. I cannot access the fancy box stuff. Well, I'm going to make it so that I can't anymore. So fancy box, I can't even try what I'm about to do. So here's an example where if I see that this is going to be something that I might find myself doing carelessly, divide by 0, which I'm lucky it didn't crash, but it certainly didn't give me any usable information. So one of the problems with the way structs are set up is that you have no control over how the data is used. So let's scrub the struct out of here and let's take control over things. So now the struct can go. And I know with the class, I can no longer directly access the X or the Y because classes don't do that by default. And what most people, as far as I can tell, will do, I certainly do, even though I know X and Y default to private, I use the access modifier to make it clear what is intended to be private. And then I use an access modifier to make it clear what's intended to be public. So most of the time, certainly in our class it will be true, but I suspect it's true most of the time in the world, that the data members of a class will be private. Most of the time in the world, the data members of a struct will be public, and that kind of drives often your choice about which to use. If you're cool with the data members being public, then a struct might be good enough for you. If you want to keep the data members private and control access to them through functions, then a class might be a better choice. So in this case, I know that I want the person to be able to divide those two numbers, but I want to head them off at a divide by 0. So instead of letting them do the work of dividing them for themselves, I'm actually just going to make a function called divide that will return the result of dividing X by Y. Now the advantage I have that the person had to come in through a function is that I can use logic in this function. So that's kind of what you think is, do I want to be able to apply some controlling logic to the situation so that some dummy can't make a mistake? In other words, is there a situation where I would not want to allow this divide to happen? Most definitely there is. If Y is equal to 0, that's a giant problem. I do not want divide by 0. So I'm just going to say, well, if they try to divide when Y is 0, I'm just going to return 0. So you try to divide by 0, you're getting 0 back, which is better than at least garbage data. And in fact, I probably should return some kind of an error, but I'm not going to. So this is what I mean by controlling logic. So a fancy box will not let you just say X divided by Y. You're going to have to come through the box and ask the box to perform the division for you indirectly. So to get a quotient from that box now, I can't just say fb1.x divided by fb1.y because those are private. I won't be allowed to do that. I can, however, ask the box kind of for its permission to run this division. And what the fancy box is going to do is it's going to check the Y, and if it's 0, it's going to head that problem off and just say return 0. So this is when I would want a class. I want to control access to the data, and then I will use functions to expose behaviors that are useful. All right, so if I don't end up returning a 0, then I can return X divided by Y. Now, in C++, these are potentially garbage data, so we may or may not get what we want. Let's see. Oh, I didn't print it out. Okay, so 32, which means that, and then we'll get into this in a second, it means that x and y weren't 0, or at least y wasn't 0. It's not known what x and y were, because in C++, unless you initialize things, they remain uninitialized. Okay, so that's a lot to take in. It takes some time to get used to this, this sort of object-oriented way of thinking. So I'm using a class. What does that mean? I want to control access to the data inside of it. How do I control access to the data inside of a class? Partly, I rely on it being private data, which means that outside of the class, it cannot be accessed directly. And then partly, I expose with the public access modifier a series of functions that allow people to manipulate the data inside, or at least run calculations against it. So let's expose a couple more functions because I don't actually know what x and y are here, and it would be handy to be able to establish the x and the y for FB1 before I run the calculation. So since the data members are not accessible, I'm going to have to provide functions for that purpose. So I'm going to do that. I'm going to go into this public section and I'm going to add some more functions. So I'm going to for now, I'm going to call this new x. So now I have a function that exposes I expose the function publicly. So what I say is you can request that x have a new value, and I will make x inside the box be that new value that was the parameter. I can also do that for y. And if I wanted to, I could not equal to 0. I could, again, use this control to not allow y to even become 0. Now, of course, that makes this bit of logic unnecessary, but it's not hurting anybody, so I'm going to leave it. So now I'm going to allow the program and its FB1 to set x and set y, but for the y, I'm going to scrub off the 0. So now in the program, I can say fb1.setX because that function is public, and I will say 10, and then fb1.setY to 2. So I'm using the public functions here. I'm going to do the divide after the change. Now I know that that y won't take unless it's something other than a 0. But technically I could forget that fact, and I'll show you that I'll forget it here in a second. So the idea of a class is that you come into the data through public functions, and then the public functions give you, the programmer, the ability to filter for things. Like, I don't want to divide by 0, and I don't want you even trying to make a y that is 0. So the public functions give me that power over FancyBox's data, since main can't get at the data directly. And this should give me a quotient this time. So the quotient is 5. And now if I do this, so if I say now I'll be cute and I will try to set the y to 0, and then try to run the quotient again. Notice I'm reusing the quotient variable. Anyway, so I'm going to try to set it to 0 and then see what happens for my quotient. it's still 5. And the reason it's still 5 is because I filtered off zeros. So y can't actually be a 0 anymore. So I don't technically have to check for y being 0 in my divide, but you never know. So I make the code as sort of bulletproof as I can. And then down in main, I just kind of have at it and see what I can get away with. Okay, so I hope that makes some kind of little bit of sense. Yeah, so let's keep going. What time is it? 10:30. Okay, so we have my fancy box. It's starting to grow. It's starting to get slightly more interesting. I mean, it has this divide function that will return a result of dividing x and y. One thing that it doesn't presently do is initialize these variables. So I'm going to do this a little bit old schooly. It still works. And the reason why I'm doing this, if you see people doing it in the sort of newer school ways to do it, is because I'm teaching it. And I'm hoping that you will understand what's going on here if we start from this kind of old school way of doing things. So one of these days in the future, I'll do the sort of new school way. But for now, for context, I'm going to do this next thing in the old school way. Okay, so as it is right now, when I create FB1, the values of x and y are unknown. They are uninitialized. And we don't like that. So when you are doing object-oriented C++ and you want to initialize your data, the way you do that is with a special function called a constructor. And I'm going to make a constructor now. In fact, I'm going to make what's called a default constructor. It's called a constructor because it is used to construct objects or instances of this class. So what's different about constructors? They have no return type. So they're functions, but they don't have return types. They're a special kind of function that looks different. So there's no return type. A constructor is simply the name of the class followed by a parameter list. That's all it is. It's mostly what is going to look like a function, and what we do with it is mostly what looks like a function. But notice that it doesn't have void in front of it. That would not be a constructor. That would be a pointless function. So this is a constructor. When you have a constructor with no parameters, we call that the default constructor. And what you do with a default constructor typically is you use it to assign default values to your data members. So when I construct a fancy box, what do I want x and y to be? I'm going to make them both be 1 to start. So when you create a fancy box, by default, with the default constructor, you get a fancy box whose x, y values are 1 and 1. This is a default constructor use, by the way. You can't see it. You can't put the parentheses in there. You just have to learn to recognize it, unfortunately. But this is a default constructor. You can, for experimental purposes, put an output in your default constructor. It's not the best of ideas. But if you want to kind of learn to recognize when constructors are actually being executed, you can use this little trick of doing outputs. Now I have used a different looking output called CAir. And I'm not going to get into this right now, but this will look no different on the screen. CAir is going to do just what a cout would do, which would be to appear on the screen in front of us. So it's just like a normal cout. There are uses for it, but the reason why I like CAirs for this is because I can go hunt them down later and comment them out or flat out delete them. So I recommend using CAirs for your debugging output. Not for your regular program output, but for output that you're using to debug code or understand the flow of execution of a program. So I've put this here because I want to know, when does the default constructor actually happen? And when the default constructor happens, this output will happen. And then I can use the fact that I use the CSCI stream, is what it's called, to hunt it down later and get rid of it because I know it's debugging output and I can delete it later. All right, so let's run it. There is the constructor executing. And that's the only way I would know that, is because of that output, but the constructor executed right here. That's really the only way I know that that's happening, is with that output, and that I learned to recognize that that's how it works. Let's make let's do its quotient, which should be 1 right here at the start, and then let me make sure I don't double up on that thing. Okay, so the quotient should be 1 to start, and then it'll be 5 twice. So there it's 1 to start, which is proof, some kind of proof anyway, that my default constructor is probably setting X and Y to be 1. Let's make another fancy box just to show you. So you have to learn to recognize this. This is default constructor happening. FB2 will be built using the default constructor. I just have to learn to recognize that. You want to put parentheses in there, but it should probably still be, it ran, interestingly enough. So I guess if you want to, you can, but no one does that. So I wouldn't get used to seeing it that. Oh, wait. Something weird happened. Hold on. Let's run it. Okay, there it is. I don't know what happened. Or maybe I forgot to click run. So there's the second fancy box being fired off. It will also have an X that's 1 and a Y that's 1. Okay, so that is default constructor. We can also overload the constructor 1 or more times. So some classes you will open and you will discover that they have multiple constructors. And the reason why they have that is because it offers multiple ways of creating instances of that class. So I would like to have a constructor where I can build a fancy box and specify the X and Y values right off the bat. I'm actually going to do a CSCI here so I can see when I use this. And it's going to be fancier because I'm going to put the new X and the new Y in the output. So I can see when this one runs, and then I want to say X equals the new X, Y equals the new Y. So now I have a second option for building fancy boxes, which is I can create them and construct them with specified X and Y values to start. So let's make FB2 be that. Let's make FB2 be 99 for X, 33 for Y, and then I can reuse the quotient. Let's say FB1. So that our output is clear. The FB2 quotient should be 3. So there I'm using the other constructor for the second box. For the first box, I'm still using the default constructor. For the second box, I'm using the overloaded constructor. And we should see the CSCI outputs, the debugging outputs happen that show me that each of those constructors is actually firing. So there's the default one with a quotient of 1, and then I make some changes and get the quotient of 5, and then I build using the overloaded constructor, and then I get a quotient of 3 on the second fancy box. So that's constructors. we'll see more examples of that. Remember data, remember function, scope, resolution. Yeah, we're doing okay. Okay, so this is a lot of stuff to take in. I know. So unfortunately, that just is what it is. You're going to get some practice for the rest of the semester. But anyway, that is kind of building a class from the ground up with a default constructor, with a debugging output in it so we can see when it fires, an overloaded constructor with a debugging input to see when it fires, and then a function that allows me to set the X value on a fancy box, and a function that allows me to set the Y value on a fancy box. The Y value filters the Y's so that they can't be 0. And then I have a function divide that just does one last extra check to make sure it doesn't do a divide by 0 before it does the actual math. And then I have 2 private data members, because that's why we like the class in the first place, is we can kind of hide the data and then control access to and filter the data with a set of functions. It takes a while to settle into this way of thinking. I know that a lot of you will just have syntax to deal with for a good long while yet. So I'll say all the things that I want you to know about it. And we'll all just accept that some of you will be fighting the syntax for a while. I hope that I'm giving you labs that let you kind of work into something that's already been created for you. And then I'll try to offer techniques that you can use to study the code for yourself, like debugging outputs. I call them debugging outputs because I use the C error stream, and then I can easily go back later and I can do like a control F, and I can find all the C error lines, and I can delete them or comment them out because I won't want them to be part of my regular program when all is said and done. So anyway, that's a trick though. Just sprinkle some debugging outputs and delete them before you submit your work, but they are a way for you to study how the code executes, what happens when. All right, so we have several improvements to make on this fancy box, but I'm going to switch and do a different theme with it. So for now, I don't want to get rid of this, but yeah, so what I'm going to do, I think, is I'm just going to comment the whole darn thing. And then I'm going to push it way down to the bottom. So when I upload these samples later, that whole fancy box program will be down there. But I want to build something brand new at the top. So let me undo. One thing that started to be irritating to me is just the amount of code I'm having to scroll through at any one time. It's a lot of stuff going on in here. I'm creating the fancy box and I'm implementing functions for it. And then I have in main my application that's using fancy box. And even though one is relying on the other, it's kind of 2 different problems to solve. How do I implement the fancy box by itself? And then the separate problem is, okay, now that I have a fancy box, how do I use it to make an application? And let me redo somewhere back to where it's way out of the way. So too much going on in one place. So one of the improvements that I want to make is I want to learn how to implement my object-oriented C++ into separate files. Implementing in separate files has multiple advantages. One advantage is that if you already have the code separated out into its own file or files, it makes it very easy to take that code and reuse it in a new project. So it makes the component that file has in it much easier to reuse because I don't have to copy and paste things. I literally just lift the file and move it to a new project, and I can begin to use it again. You're seeing that with doc test as an example, right? We don't have to touch the code in doc test. We just have to get the code, the file that is the code into our project and we can use it. So we want that. That's one advantage, is simply ease of reuse. The other advantage, though, is that when you are implementing your code that is your class with its data members and functions, you want to be focusing just on that part of your problem. You don't want to be thinking about what is my application going to do with all of this. You just want to focus on what does the class do? What are its data? What functions do I want to expose to make using this class easier in an application? And then you can switch back to the application part, main.cpp, and later worry about, okay, now how do I use that component that I created? So let's make a separate component. What do I want? I had a couple ideas. Yeah, let's do it's a boring one. I apologize for that, but let's implement ourselves a class to represent a tweet on Twitter. And no commentary on Twitter. It's just that most people are familiar with the idea that the tweet has content, and the tweet has likes or dislikes. You could also think of this as a Reddit post. But anyway, let's just call it a post, and we'll have upvotes and downvotes, and a number of views and that kind of thing, just to make up some data that we can manage. So how do we do that without working inside of main.cpp? Well, the first thing I'm going to do is create a file, and I'm just going to call it post.h. So brand new empty file, post.h. The .h part stands for header, or headers, depending on who says it. So when you are creating a class, you can do this with structs too, by the way, but you'll often see people do this with classes. The .h file tells me that what I should find in here are headers. And what do headers look like? Headers are all of the declarations of things. So function declarations, variable declarations, those are what we would consider to be the content of a header. So let's make a header for post. You're going to see this in all of the headers we write in this class, this pragma once. This one's harder to explain, so for now, just let it be there and let's focus on the class part. We will explain what this is, but we've got kind of multiple new things to deal with. So make sure the pragma once gets in your header, and we'll worry about the specifics of it later. Now we're going to declare the class, post. My style is my file names. I always use all lowercase letters. You don't have to, but I just do for whatever reason. I like the way it looks. But my class names are always capitalized. That borrows from the Go language, from the Java language. A lot of languages use this style where class names are capitalized. Get that semicolon in there. So here goes my class, post. I'm going to go ahead and set up. The public section will be my public functions, and then the private section will be my data that I am controlling access to. So what data will I have for a post? Well, I will have the content of the post. Because the content of the post is a string, I'm going to have to include string, and I'm going to need to using to get it in here. So hopefully that's not too much to take in. I'll upload all of these samples. And then you'll have the lab, which repeats the same kind of process, although a lot of it, you won't see it built from the ground up. Okay, so why do I have these here? Because I want the string as one of my data members. So every post will come with its content. Every post will also have upvotes, downvotes, views. And later we could be fancier and we could have like an array of tags or, but for now, let's just have these basic things. I made them unsigned integers because there just will never be negative upvotes or a negative count of downvotes or a negative count of views. So those will all start at 0 and work their way up. Okay, so now let's declare functions. So because we're doing these things separate, we're going to declare things in this header file, and then we will implement them in a separate implementation file. So all we're going to do in here is function headers and variable declarations. So what functions do we want? Let's make a default constructor, a constructor that will build an instance of post with no arguments to it. Let's build an overloaded constructor. And I'm doing this slightly differently this time to force something new in. Anyway, so I have the default constructor. I will have an overloaded constructor, which will allow me to build a post by specifying its content at the moment of its origin. Okay, let's see. What else do we want? We want to be able to add an upvote. We want to be able to add a downvote. We want to retrieve the number of upvotes. We want to be able to retrieve the number of downvotes. Now I'm saying, why do we have to, hopefully everyone's starting to think about, why am I doing this? Why am I writing public functions for the purpose of upvoting? Why don't I just do upvotes plus plus? Maybe I'll leave that question hanging. So why am I writing functions both to increment upvotes and downvotes and also to retrieve their values? Why am I doing that? Which is a hard question. Okay, so probably have people stuck a little bit on this one. Because all of the data members are private, any activity that you might want to perform with this data in your application, you need to write public functions that allow that activity. So in my application, one of the things I want to be able to do is I want to upvote a post or downvote a post. And since I can't just directly do that, I actually have to offer a function for that purpose. And then in my application, I might want to actually view specifically how many upvotes does this tweet have and compare, or this post have and compare it to others, or how many downvotes. So I'm thinking in these functions about what might I want to do in my application with that data. Well, I want to be able to alter it by incrementing it. And I also might want the ability to view it. All of which require functions now. So a lot of people will begin to say to themselves, then why don't I just make this a struct and make that much easier? And it's going to often feel that way, at least until you kind of lock on to the idea. It's going to often feel like you are causing yourself to write a whole bunch of functions that if you'd have just used the struct, you wouldn't have to write. And that is true. You are causing yourself to write functions that you wouldn't otherwise have to write. But it's good practice when you are using a class, because the expectation is that a class is going to make all of its data private, and there must be some reason for that. We might want to, somewhere in here, apply some filters. So yes, just accept that, especially when I'm forcing you to use a class, you may be implementing functions that could be eliminated with a struct or with public data members. So yes, that's true. In the meantime, just imagine if you were taking this and using it for an application, would you want to view the different pieces of the data? Probably. Would you want to be able to increment the voter system? You would. You might also want to change the content. This is something that Twitter, I think, has started to allow as edits of posts at this point. I'm not sure how that's going to work out for them, but let's just say in our system, you can go edit a post. So to do that, we can't just go directly to the content. We have to provide a public function that would allow for the purpose of changing the content to something else. Often you'll see people call these kinds of functions setters. So it'll be set something. So set the content. I'm not saying set upvote because I'm not setting the upvote. I am upvoting, incrementing. But set when you want to change the thing wholesale. And then the getting, I should probably do that for getting the content. So these are often referred to as getters because people will put the word get in the name of the function whose design it is to get that thing. So I have a function that allows me to retrieve and read the content of a post in my application, to retrieve and display the number of upvotes, retrieve and display the number of downvotes, retrieve and display the number of get views. And then I am anticipating, and this is because I want you in part to do this pretty much always, it might be handy to have a function that kind of takes all the data and puts it together into one nice looking string that could be used to just kind of quickly print out a summary of the entire contents of a post. So that's what this one will do. So I'm not doing documentation in here. You'll see in the labs that I do, but in here I'm trying to get to the teaching of the syntax. So there's my public functions. If there is some kind of functionality that I didn't think about, I can always come back and add more functions later. But this is what I imagine is the initial set of functions. A default and an overloaded constructor for building post objects. Functions for altering the data of a post. I don't have adding to the views because what I'm going to do is every time an upvote happens, I'm just going to add to the views. And every time a downvote happens, I'm going to add to the views. So I'm not going to ever directly manipulate the count of views. I'm just going to use the votes on them to be their views. And then I have a series of functions that retrieves the individual pieces of data for each post. And then finally a function that will put everything together in a handy dandy formatted string so that in my application I could just say, oh, I just want to quickly dump out a summary of the post. And this function will do that for me. Okay, so that is headers, post.h. I called it post because the class post is in it, although I like to lowercase my file names. You don't have to. And then I uppercase the class name because that's a common style that I also use. All right, constructors, data manipulators, if you will, data retrievers, and then the all-in-one handy-dandy everything at once formatted string, which we started to explore last week with the item. That's headers. And the reason why we call it headers is notice that there are no blocks of code anywhere. This is all declarations. So it is variable declarations, it is function declarations, and now we're going to go implement this stuff. And then all of that stuff, notice, is inside of this class post block. And that's important because it affects the syntax. Okay. You know what I know I'm going to need? I know I'm going to need these things when I go to implement stuff. There's my headers. Now let's do the implementation. So now let's do the file where we actually implement these functions. So I'm going to make a new file. I'm going to call it post.cpp. So the .cpp is a way that we can quickly tell that there is code being implemented in here, whereas the .h file tells us that there are likely headers in here, declarations of things. So .h, declarations of things. .cpp, implementations of things. Okay, so let's go implement. So the first problem we have to solve is that how does C++ know that this CPP file goes with that H file? You tell it. So I'm telling C++, hey, you need to go read the declarations in post.h before anything else. Notice I use quotes for the include because these are two files in the same folder in a project. So this tells C++, hey, go find post.h in this directory, in this project, and read the declarations inside. So when C++ is finished with that, it already knows about all the stuff that I declared, and now it will begin to look for implementations of those things. The way I do this is I go to the header file and I do basically what C++ just did, and I read them. I copy them. Notice I'm just grabbing the function declarations or headers. So I'm copying those and I'm going to paste them into here. By the way, these are all tabbed over one. So I'm going to highlight them and I'm going to hold down Shift and Tab should pull them back. Shift Tab, pull them back. Okay, so that's the first step, is to begin to match what C++ saw when it went and read those declarations. The second step is to fill in the full picture of what C++ saw. So here's a weird new thing. When C++ went over here, it had to actually go down into the class post to find these things. So it found this default constructor in the scope of the class post. So this default constructor is sort of a child of the class post since it's inside of its block. So I also have to do something with that because C++ doesn't understand this default constructor to be just something that was declared by itself. It understands it as a child of the class post. So I have to tell C++ or remind it that that is the fact. Hey, remember that class post that you read and that default constructor post that was inside of it? That's the thing that I am here going to implement. We call this scope resolution, by the way. So how do we help C++ resolve this default constructor to the scope of this class with the scope resolution operator? It's a lot to take in, I know. Okay, so here's another. C++ only understands that there's an overloaded constructor called post in the scope of the class post, so I remind it of that. And then I'm going to implement that here in just a moment. And then I have to do the rest the same way. And you do the function names, not the returns. So, hey, C++, remember that function set content that was in the class post? Going to implement that here. Here's another one, upvote, that was in the class post. Going to implement that one here. Downvote, which was in the class post. Going to implement that one here. Notice I'm taking the semicolons off because these are no longer headers. These are full-on function implementations. The function get content, which was in the class post. implement that one here. Get upvotes, which was also in the class post. Going to implement that one here. Get downvotes, which was also in that class post. Implement that here. It looks like a lot of syntax. Eventually, it just starts to look nice. It looks orderly, and it begins to make sense if you sort of think about what C++ can do in terms of interpreting the code that you've written. And then finally, the function toString, which is in the class post. Going to implement that one here as well. Okay. So now I'm all set up. I have done scope resolution to the class on all of the functions that I brought over from the header file. And now it's time to implement them. I might remind myself by looking at the header file of what the variables are. In fact, I might just kind of copy those and put them at the top of this file while I'm in the process of doing this work. So I'm going to comment them out, but now I know what variables I have access to. These were also declared in this scope. Okay, so content. That's a string. It will be empty string to start, but I think I'm going to override that. So one more new thing, because I think it will help you keep things from being ambiguous to yourself. So you may have seen this in other languages or something like it, self. In C++, you can actually have in code an object kind of refer to itself and its own data and functions. So when you see this with the arrow after it, the idea is that it is a post object referring to itself and its own data. And it's a good way to disambiguate code. Disambiguate simply means to make unclear meanings clear, is how I would say that. So every post has content, and I think that I am going to say empty post as the content. And then I'm going to say its upvotes will be 0, its downvotes will be 0, and its views will be 0. So in this default constructor, the idea of disambiguating something is not going to make sense right now, but it will in just a short moment. Okay, so this is a reference to the post itself, and that's difficult to understand. Every instance of a post is itself. And I'll try to come back to this idea to help you make more sense of it. I'm waiting for Replit to reconnect. Okay, so that's the default constructor. I don't want just content being empty string, so I actually put the words empty post in it. Okay, so now let's do the overloaded constructor, and this is a case that needs disambiguation. So I have the data member content, and I have the function parameter content. Which is which? How is C++ supposed to know which content is which content? Is this content the parameter? Is this content the parameter? Are they both the parameter? Is one of them the data member inside the post, or the other one the data member? So this is a case where you need to disambiguate. You need to tell C++ which is which. So to make C++ understand that I want the parameter content be on the right side, I will use this to disambiguate it. So now C++ understands, oh, you mean the content that goes with the post and not the content that goes with the parameter. And I set that situation up that way on purpose so you could see the disambiguation happening. The others of them can be simply exactly the same. So you can build a post that's just going to be empty to start with zeros, or you can build a post with specific content and then otherwise zeros. Set content. So I think all we'll do in this case is we won't, and in fact, let's filter. Since we have the power to filter, let's just say if the content is not empty, let's only allow setting of the content to other content and not nothing. So as long as the content is not empty, then we can say the content of this post is the content being provided as a parameter. So that one I used the private data members and the public functions to filter. Upvote. So that will be a this upvotes plus plus and a this views plus plus. So I'm just going to assume that my application is set up so that you have to upvote or downvote, and that goes along with viewing the thing. Downvote will be this downvotes plus plus, and also will count as a view. So the reason why I don't have the ability to directly adjust views is because you have to upvote or downvote to view in my system. Okay, so there are the ones that adjust data. The get content, well, that has a string return value, and I'm going to return the post's contents. The upvotes, I will return the post's upvotes. The downvotes, I will return the post's downvotes. And I know this is a lot of just like manual labor for what good reason, since I could have used a struct. That's all true, but remember that the default sort of desired behavior of a struct is that it's the wild, wild west with the data, and you don't care what people do with the variables. When you use a class, you're doing that because you probably imagine that you want to be able to do things like add some filters on the possible alterations to your data. So in the case of content, for example, because I'm in a class, because the data is private, I can control changes to the content, for example, by not allowing empty content. I should have, by the way, done that in this constructor as well. I should not allow you to construct a post with empty content. So yeah, I'll also do that in the constructor. If you try to build a post with no content, you're getting one that has the words empty post in it. Where were we? Oh yeah, down here. So return this views. So these don't seem to be doing much other than allowing a person to view those values. That's true, but these are read-only getters. So they can retrieve and view the values, but they can't use these functions to alter those values. They have to go through my functions that were designed for that purpose. So in theory, they could abuse this with a loop that upvotes 1,000,000 times, but at least it's some kind of control over the way the posts are used. To string. So this one's going to be a bigger pain in our rear. So immediately set up for that. And then I'm going to just quickly do this because I'm starting to run short on time. So I'm going to use this to sort of try to make things look a little bit prettier. So I'm going to say if this content dot size is I don't want to spend a whole lot of time on this, but let's just say if this content dot size is greater than 10 characters, let's say, then the output I don't want to put the entire content out if it's a super, super long string. So I will put a substring of this content. Starting at character, I don't know. Well, start at character 0, and I will go to 10. So all I've done here, I think, or at least I hope, is I've cut off the first 10 characters. And then I'll tack on an ellipsis to show that I elided the string. But if it's shorter than 10, then I'll just put the whole thing. Seems okay. I need to be careful that I am putting some spacing after it. And then I'll just do, I'll put a space in there. Put the views. And then I'll continue it here. Votes. I think I want a parenthesis right here, just so I can see what's going on. And then I'm not in the habit of putting end lines on these things because where I use it may or may not demand the use of an end line. So I may have to come back to this, but there's another example of creating a formatted string. So one thing to notice here, nowhere in here did I do a cout, and that's on purpose. I don't want couts just everywhere. I want couts in the application. I don't want couts in the components that I'm using to create my application. I can do debugging outputs if I'm still curious about that. So I could put debugging outputs in here. So I know, hey, the default constructor just fired off. And then I can disable them when I'm done. But let's put a couple in. So these are debugging outputs. So I use CErr so that I can easily come back when this application is ready to ship or submit and delete these or at least comment them out. Now I have to do an include for these things, and this is sort of the last message for the moment. The only include that I want to see in a .cpp file is its own .h file. If you need to add includes, because you are going to use some library or some portions of a library, put them in the .h file. Now, why do I want them in the .h file and not the .cpp file? Because the .h files are often used as a form of documentation. So if you were to give me a .h and a .cpp file, what I would expect to be able to do is open the .h file, and I would understand what dependencies you had on libraries. I would see what functions you had publicly available, and that's all that I should need to know. I don't care how you implemented this stuff. I want to know your dependencies, and I want to know your public functions. And I should be able to get all of that, the dependencies and the public functions, from the .h file without ever having to look at any of your messy implementation. I don't want to dig through this. I only want to open this file and get a quick view of what it is I've got to work with. Mess that one up. So these are for debugging, and I might try to remember to clean those out later. This one's also for debugging. In fact, I might just group all those guys into one place together. And now I've sort of made a note to myself that this stuff is debugging stuff, and I can get rid of it when I'm ready to ship. Okay, so now we have headers, we have implementation. We've done nothing to see if any of this code works. So let's go to our application and see if any of it works. So we will include post.h. That's all we need to use that entire implementation. Replic's going to handle the problem of compiling all the stuff that's needed to compile. All I need to do is make sure that C++ knows who is needed and where. So those definitions in post.h, I need them for my new application. Let's just start with that much and see if I have an empty post with all zeros everywhere. I do. And I also have the debugging output that showed me the default constructor was used. So let's upvote it. And that should give me one upvote and one view. All right, you get the idea. I didn't put the downvotes in just to save time, but it may not be something that I want to include in this little summary. We'll go ahead and make a, should have called that, well, I'll just call this one P2. And let's give it some content. So, there's my post. And I'm trying to put in more than 10 characters because I want to see if my little elision. In fact, I should put a non-10 character one to see what it looks like too. And notice that I can simply just add a new line as needed in my application, so that's fine. The toString isn't going to do that, but I'll do it for myself. Okay, and then let's make one post P3. Is that 1, 2, 3, 4, 5, 6, 7, 8, 9? Oh, that's way. I need to be less than 10 to test out my little elision algorithm. All right, so there's 3 of them. I'm just going to let this one be upvoted. There's the overloaded constructor, and there is the elision happening where it kind of just dots it after 10 characters, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. And then apples, which wasn't dotted. So there you go. There is my little object-oriented system. So I will I will upload to the lecture page post.h, post.cpp, and this main.cpp that has the, or what I might do is just put a link to this REPL since it's public and let everyone get at it that way. Either way, all this stuff will be accessible. The first example with the box is way down at the bottom here. I'll put it a little bit closer so you can see it. And otherwise, I want to go look at the lab before time is up. So this object-oriented stuff, there's a lot of syntax involved. Hopefully the lab is a little bit softer landing than the examples that I just gave. Because since you have the lab that's kind of pre-built structure for you, I wanted to show you building something from the ground up. So just be patient. We will get to repeat this process of creating a header file, creating an implementation, doing all the includes, and doing all the scope resolution, and using this with the arrow. We'll get to do that a whole bunch of times. So plenty of practice of that ahead. Yeah, let's go look at the lab before we shut down for the day. Okay, so the Lab 5 repository. So it has a driver, or the application part, and then a bank account header and a bank account implementation file. Let's look at the header first, see what's going on in here. There's the Pragma once. I will talk about that hopefully next week. These are the dependencies for the bank account. You do need to document it. And then we'll see headers. So default constructor, and it tells you what values it expects to find for the balance in the account number. So when you look at the .h file this week for lab, you will notice that it is documented, commented to tell you what to do. So the comments are in the header file, and you will need kind of just to have those in mind, or if you want to copy them over, whatever you want to do. These will direct you to what to implement. So default constructor, balance 0, account 0. Overloaded constructor number 1, balance 0 with a specified account number. This is a place to use this arrow to disambiguate. Overloaded constructor number 2. So this one has 2 overloaded constructors. In this case, it starts with a specified starting balance and a specified account number, which will also be handy to have this arrow to disambiguate. Depositing funds. So that will simply increase. You did a function like this last week with the item where you added an amount. So that's all it will do is increase the balance by an amount. Here is a withdrawal, which you have to be careful of because they may be trying to withdraw an amount that is more than they have in their balance, and you should have logic to deal with that. This is a good example of why we like classes, by the way. If we were using a struct in its default state, someone could simply say account dot balance minus equals whatever with no filtering. So this class allows us to filter the withdrawals to make sure that not more than what is available can be withdrawn. Getting the balance, that's pretty straightforward. Getting the account number, that's pretty straightforward. Returning a string, there is a template here. And then there is an example with some sample data inside. This one will want last week's magic formula to do the floating point part. Check for the new line. I suspect the unit test will not be looking for a new line here. And then the 2 private data members. So what does the header have in it? It has the declarations of everything that's needed, and it has the documentation that tells you what the functions are supposed to do. What does the CPP file have in it? It has the include that ties the 2 pieces together. And then it has already done for you the scope resolution on all the functions. There's the 3 constructors. So the scope resolution part has already been done, and the empty blocks waiting for your work have already been done on all of them. And on the toString, I also left you with a little setup here to remind you that the little O-string stream that we learned last week is to be used. Okay, and then what does the application do? It's a unit test. So we don't touch the application. All we do is implement code in bankaccount.cpp, and that is it. Everything else has already been built. So we implement bankaccount.cpp and we click run. The one thing that's new about the tests, which is a very trivial issue, but the tests are broken out into 3 separate cases. So there is a test case that is written against the default constructor. So there's a whole bunch of situations it checks for. There is a test case where an account number is given, that overloaded constructor. And then a couple of situations it looks for there. And then finally a test case for the constructor that accepts an account number and a balance to start. And then it looks to see if the data looks correct for that test case. So it doesn't change you clicking the button, but the output will look a little bit different because the unit tests have been broken into 3 sections or test cases. That's a lot of stuff. It's not really, it's a lot of stuff for the brain. It's not a huge amount of stuff for the fingers. So the constructors are trivial, or at least I hope you find them trivial. Depositing is trivial. Withdrawal requires some logic. That's non-trivial. Getting the balance is trivial. Getting the account number is trivial. And the toString is non-trivial, but very much like something you did last week. Yeah, so that's everything. This is, I hope you find this is like the point where we step across and start using the powers that we have acquired with many hours of coding work. So now we can start to build more complex software systems. Once we have this, there's actually not that much new syntax left. And you will see the new syntax in future weeks kind of paired with algorithms. And hopefully that makes that easier. So you can write a function, run it against a unit test. You can write a struct with functions and run those against a unit test. You can write a class that contains functions and run that against a unit test. And we have got a lot of most of the toolkit we need to start doing some interesting algorithms. So I hope the lab goes well for you this week. Piazza, office hours, Canvas inbox, as always, are available as channels to get help. Please consider having a look at the first project, if not getting started on it. It is not a hard project. You can make it less complicated or more complicated. There's a few requirements. Make sure you read them. But you have some room to make choices for yourself on the first project. The problem itself is not a big deal. It's mostly counters and a little bit of math. Okay, I'm going to stop there. I hope you have a great week. If you are able to be here for the live stream, as always, I appreciate it. There's a lot of new stuff going on, so please take advantage of your channels for getting help from me and your classmates. And I will see you on Monday next week. Thank you, Edcast. You have a great week as well.